Hello everyone. In my previous electric drill video, I found out some of my drills need better power cords and safer plugs. And there's some very old drills that need internal maintenance before using them. Be sure to check that video out. I'm fixing the drill in this video just for its sentimental value. It belonged to my father, so even though I'll probably never use it, I want to keep it in good condition to maybe pass it down to the next generations. I'm working on an electric drill in this video, but the same methods apply to pretty much any small power tool. I'm refreshing my dad's early 1970s vintage drill. It's either Craftsman or Black & Decker. I'm guessing it's a Craftsman. Let us know in the comments if you recognize it. So let's get to it. So this drill has a very stiff cord, and it's really old, really stiff. The plug's in good condition, but the sheath here has broken away from this extremely stiff strain relief and slid down the wire here, so there's 3 exposed single conductors. I'd like to repair that. But this cord is so stiff. I'm going to go look and see if I have another cord I can use on this drill. I'll be right back. Okay, let me see what I have here. First of all, I'm guessing these are 16 gauge. Try to see if there's any writing on this cord. If there ever was, it's long since worn off. I'm sure it's 16, but I'm going to test the drill and just see how much current it draws with a kilowatt meter. $120 volts, 0 watts. Let's see what it takes. Something like 250 watts. Let's see amps. That's really what I need to know. It's a 2 amp motor. So certainly a 16 gauge will be plenty enough for it. 16 gauge cord. So I'm going to start this repair by getting rid of the old cord. The only thing I need here is this rubber chuck key holder that's on here. See if I can rescue this. I stood on these wires on the floor and stretched the cord up. It went well above my head. This is longer than 6 feet. So that's a good cord to use. This does have some molded writing on it. I don't think it really matters, but let me just see if I can see what it says. It's upside down writing. Go this way. It's a SJT cable, 105 degrees centigrade. Oh, that looks like it's 18 American wire gauge, 300 volt rated. That's 18. Let me cut this end off. Yeah, it's a very fine wire. I think it is 18, it's not 16. But I just measured and this drill takes 2 amps, so this 18 gauge cord is going to be plenty good for this. If you're up for an NEC code practice question, I'm pausing here to allow you time to look this up. Use your NEC codebook or your free online NEC code access to look this up. I recently posted a video about that free NEC access. Find the code references and the answer, then resume playing. Okay, here we go. We find cord characteristics in table 400.4. Type letters SJT are here. The trade name is Junior Hard Service Cord. It's rated for 300 volts, and its insulation and outer coverings are thermoplastic, and it's suitable for use in damp locations. We find cord ampacity ratings in table 400.5A1. First, we can see this is the correct place to look for type SJT cord ampacity. Let's look at the copper conductor size column for 18 gauge. Depending on the definition of column A and column B, we see 18 gauge copper cord is rated for either 7 amps or 10 amps. Note 1 at the bottom of the table indicates the currents under column A apply to 3 conductor cords and other multi-conductor cords connected to utilization equipment so that only 3 conductors are current carrying. Note 2 at the bottom of the table indicates the currents under column B apply to 2 conductor cords and other multi-conductor cords connected to utilization equipment so that only 2 conductors are current carrying. Since we have only 2 current carrying conductors in our 18 gauge 3 conductor cord, note 2 takes effect, and we're using column B to determine our 18 gauge cord ampacity. So the answer is 10 amps.
It's a nice heavy sheath on it, heavy duty. It's going to protect it well. So the bottom of this handle, it looks like there's supposed to be 2 nuts with screws. There's only one of them here, but there was 2 originally. Take that out. Of course, it's not tight. Then there's 2 Phillips screws on the back.
Notice the ground wire lug orientation here. I'll need to keep that in mind during reassembly.
There's a bunch of stuff in there that is mainly like sawdust mixed in with the grease.
It was full of gunk.
The 3 wires from the cord go directly into this switch, the trigger switch. I'm not sure how they connect in there. Well, it looks like it's kind of a stab. Let me see if I can release those. Alright, so first of all, I'm going to make room to work on this by cutting these off as close as I can to this grommet. That gives me more access to the back of this switch. Which does appear to have stab-in connections here. And these wires it looks like they are going to just pull right out. If I can get something in there to help release them. Oh yeah. Pulls right out with, just takes that point in there right next to where the wire stabs in to unlock them. And the end of these wires are tinned with solder. So I'll have to tin these with solder. So I cut the strain relief off that flexible part that's too stiff and not flexible. So it'll leave me with this rubber grommet that will just sit in the end like that, and the cord goes in there. So it's squeezed in here like this. That has to be the proper orientation. There. So now the cord will be held tight in this rubber grommet here. I just have to finish getting the rest of the sheath out of here. It's kind of stuck in there. I'll keep working on this. I pushed the cord into that grommet there. It's a tight fit. It's not going anywhere. Okay, this is rosin core solder. It's 60% tin and 40% lead.
Soldering flux cleans the surfaces to be joined, removing impurities and ensuring a better bond. But don't breathe the smoke.
See if this old soldering gun will heat up. Oh yeah. I don't exactly want to breathe that lead. Okay, so I took a toothbrush and cleaned it all out gently, the best I could. Got all the hardened old sawdust and whatever loosened up and out, and then I blew it out with some compressed air. That's pretty good. It looks pretty good. And then this bearing on the motor shaft, you can see it turning here. I put 1 drop of oil right on the top of the end of the shaft there. I set that in the vise and I let it just sit there and soak in, and then occasionally rotating it, also grabbing it by the commutator here and kind of pushing down and up. It moves about a 1/16 of an inch, but you could see it was working the oil in. If I try to wiggle the shaft in that bearing there, it's a bushing. I can see the oil moving. So there's oil in there now. So that's lubricated for the first time in several decades. All right, and then here's another tip for you. I was getting ready to push these tinned wire ends back into the switch, and I absolutely couldn't remember which way they came out. And this red wire was also pulled out. So I actually went back and reviewed the video of disassembling it. So I made a diagram so I know where all the wires go on the back of this switch. So there's a tip. You should either make a diagram before you pull it apart, or take a picture. Because you know when you go back to put it back together, you're not going to remember. So black goes here, according to the official drawing, and white goes up here. And now I need to put a ring terminal on here so I can connect the ground wire. The ground wire, which I cut. to remove it is screwed onto the back of this metal frame here tightly. Okay. There it is on the back of the motor. Well, I've got to clean this out before I reassemble it. So I'm thinking before I finalize this reassembly, I'm going to go ahead and plug it in and test it out. Make sure it runs properly so I don't have to take it all apart again if there's a problem. So here we go. Looks good to me. By the way, this motor does have brush holders with removable brushes, and you can see screwdriver marks on them where they've been removed in the past. I'm not going to bother removing them and inspecting them because this drill isn't really going to be used that much. It's running good now, that's good enough. And I'm afraid if I remove a brush, there might not be enough left of it to reinsert it. So it's running, leave good enough alone. This drill really isn't going to be used, so I don't need to tempt fate and get into taking it apart. All right, let's see if we can get this thing put back together. There's a half circle there. That's where the trigger lock goes. Okay, I made a mistake. That lug is blocking the screw hole under here. I've got to move that lug. That's the ground wire lug. Sheesh. That ground wire lug keeps getting in the way. Okay, there. Just these wires all need to go in toward the back.
The grommet has a square side, so it only goes one way. Then the wires get pushed in behind the switch.
The button works. The trigger moves and the trigger lock button works. I think I managed to get that all back together again. I still need to put a screw here, actually a couple screws. I'm going to have to find another one because it was missing one. And this side of the case has a nut holder molded into it. It's a hex. There's a hex nut hole molded right into it. Okay, it's back together. Tighten these down. The screws on the back are tight. All right, let's test it again, see if it still works. Very good. It's got a healthy new cord on it. Running good. It's been cleaned out back here and lubricated. So now I'm going to pull this nose cone off and see if I can do some cleaning and lubricating in there. So there's 1, 2, 3 screws holding the front nose cone on. I call it a nose cone. I'm not sure if that's the technical term for it, but seems to fit. Okay. Now let's carefully pull this out. I'm just going to brush this area out. It's got some built up, like greasy sawdust in there. But if you get this far, don't pull the armature out because the brushes are in this end, and then you won't be able to reinsert it without opening this end again. Oh, look at that. Well, that's actually helpful. Kind of a metal guard plate to help keep crud out of the motor, which it definitely didn't do very well, but better than nothing. I'll clean that up. All these wood fibers I see in here make me think back to my father's projects when he used this drill on them. He built a lot of sort of modern furniture pieces. And I'm going to go blow this out with some compressed air after I brush it out some outside. So that's what that looks like. It's quite a bit cleaner in there. I'm going to put a drop of oil on this thrust washer and on the motor shaft, of course. But then this was also full of crud, and I cleaned it out quite a bit. I'm thinking I'm going to try to pull this assembly off the back here. It's actually just a cover for the assembly. Doesn't exactly want to come smoothly, but there it is. And there's all that ancient, stiff, hard grease that's in there. So this needs a real cleaning. Gotta clean all this grease out and put some fresh grease in there because this is disgusting. That bad grease, well, it's actually not even touching the works here. But I think the works need a little lubrication, including this ball thrust bearing and these shafts, which have been running dry for decades, fortunately not being used. This all needs to be cleaned out and relubricated. So, welcome to 1973. This grease that I scooped out of there, I kind of dug it out of there with a screwdriver. It's just sticky, old, turned into glue, useless grease. And I'm going to clean it out and replace it. And you know, this old drill is probably not worth all this trouble, but I'm doing it just for sentimental value. This was my father's drill. Gonna go blow it out. That's about as good as I can get it. Well, that looks pretty good. Just gonna go use some compressed air to blow it out and dry it out. Well, my grease supply is a little lacking, so I'm stuck using this, whatever it is. Here it comes. Sure, it's some type of general purpose grease, but at least it's not 50 years old and hard as glue. This is actually the grease I put in on my finish mower. It's a little thick. But again, at least it's not that hard, gooey. It's both hard and gooey glue. Grease that was in there for the last 50 years. I'm going to put some 3-in-1 oil on these bushings, these bearings. Oil everywhere. Well, I can't complain that it hasn't been lubricated. Just pour it all over and let it soak in. Well, let's see what it sounds like. That actually sounds better. Or is it just my imagination? I just want it to sound better. Not sure. This chuck is a little sketchy. I'm going to put some oil on it, just 1 drop, 3-in-1. Ah, there we go. Look at that. Perfect.
Thank you for watching. Please take a moment to like and subscribe.
Okay, that's that. Time to put this back into storage for basically, I don't know, maybe the rest of my life.